And the question is, first, how many 5-digit numbers can I create? Very easy question. Everyone knows by now the answer. 5 factors 8. Here we have 2 identical 2's. That's why I created the example this way. So since we have 2 identical 2's, you have to divide it by the relative order among the 2. So it's going to be 120 divided by 2. So it's 60. Yes, I'm sorry about that. That's why I construed the example in this way, so that it contains 2 identical even numbers. Okay, so back to B, how many odd numbers can I create? Now, here are the 5 slots, and I want to first consider the condition. The condition is that this one has to be an odd number. I have 2 choices. Either I put here 1 or 3. So that means 2 possibilities. So that's going to be a factor of 2. What about the remaining 4 slots? In the remaining 4 slots, let's say I put 3 here for the sake of argument, I have to place these 4 digits. Well, they can be ordered, as we know, in 4 factorial ways, but here are these 2 identical 2's, so I have to divide it by 2 factorial, which gives me 12. So the final story is going to be 12 possibilities here, plus 2 possibilities, because I still have the choice whether the last digit was 1 or 1 or 3. So the final answer is 12 times 2 equals 24 cases. Okay, let's see the next one. How many even numbers can I create from these cards? Looks easy after that. So let's start and see whether it's going to be exactly the same way of solving it. 5 slots. Since it's even, I can put here 2 or 6. So far so good. Now, there's a problem. If I put 6 here, then in the remaining of the story, I have 4 digits, out of which 2 are identical, so I will have to divide it by 2. However, if I put 2 here as the last digit to make sure it's an even number, then one of the 2's are used up, so I'm going to have 4 digits, none of them are identical, so the possibilities here are going to be 4 factorial, no division. So that seems to suggest that I cannot tell the story together with the last digit 4, last digit 2, and last digit 6, because they are not identical. This is a typical problem when you have an asymmetry in your story. So then you have to consider the 2 possible ways here how the even condition can be satisfied. The first one is when you have 6 at the end. Then the story goes like here. I have 4 digits. They can be ordered in 4 factorial ways, but 2 2's are identical. So therefore, this is going to be only 12. This was 1. So this gives me 12 cases. And then consider the second possibilities. When the last digit is 2 as a fixed digit, then I have here remaining 4 digits, no repetition there, so the possibilities end up 4 factorial. So in this case, I have 24 cases, which altogether gives me 36 cases for the even numbers. Okay? I hope it's clear that you couldn't solve it together, so that you don't differentiate between the 2 cases. Okay? Now let's see, how many even numbers can I have so that it starts with 3? If there's an extra condition that it starts with 3, you still have the same problem, so now we are clever And we start with this distinction, namely the last 4 digits then are such that the last is 6, or they are such that the last digit is 2. Now 3 is fixed as the first digit, 6 is fixed. I have here 3 slots to put these 3 digits. That could be ordered 3 factorial ways, but 2 are identical. So this is going to be 3 cases. However, in this story, I have to put into the 3 slots 3 different digits. So that's going to give me 3 factorial, which is 6 cases. So altogether, I have 9 cases such that it's even, and it starts with the digit 3. Okay. Okay, the very last problem I would like to discuss today involves our familiar cards again from 0 up to 4. And the problem is again 5-digit numbers, but now I want to consider separately odd numbers and even numbers. If you have odd numbers, then the story is pretty straightforward now. The last digit can be 1 or 0. So I have 1, 2, 3, 4 digits left for 4 slots. 0 cannot go into this place. So I can only put here any of the remaining 3. Let's say I put 1 there and 2 into this, so 1 is there, 2 is there. Now again I have 3 remaining, but 0 comes back into the picture, so I have 3 and then 2 and then 1 possibilities, which ends up, and here is a 2 for the choice, so that altogether is 36 cases. Yeah? Okay, let's see even numbers. Let's try to start the story again the same way. I can put here 2 or 0 or 4. Familiar problem. If 0 is here, then I don't have to consider it whether it goes into the first place because every card is used only once. However, I chose 2 or 4 there, then 0 comes into the picture here as a problem. Therefore, we resort to our well-known technique by now. Namely, let's split it into 2 separate cases when it ends with non-zero and when the number ends with 0. If it ends with 0, then the remaining 4 cards go into 4 places. Nothing complicated about that. That's 4 factorial. However, in this case, I still have 0 to choose from, so I have to make sure it doesn't go into the first place. Therefore, here I only choose from 3 cards. Then again, I can choose from 3 cards because 0 can be chosen, then 2, then 1. And because of the original choice here, I have an extra multiplication of 2 there. So that's exactly, again, the same number of cases, 36 cases, and that was 24. And in these cases, we have addition. We have to add them up because they are 2 complementary ways to satisfy the condition of having an even number. So that's 60 possibilities altogether to have an even 5-digit number. Let me note, just as a final remark, that here in this problem, it could have also worked to say, I don't care about 0 being in the first place. Let's use again the codes. I have this many 5-digit codes, which are even. Here it can be any of these 3, so that's 3. And in the remaining 4 places, I can have any order. 0 may be in the first place, maybe not. And then from these all even 5-digit codes, I'm going to subtract the bad cases, which are still even. So it starts with 0 or 2 or 4. But 0 is fixed in the first place. This reminds you that there's a 0, and the remaining 3 are all the three possibilities. 3 factorial. Yes? And this gives you exactly the same result. So, no, sorry, it has to be 2 here because 0 went there. So that gives me 24 times 3 minus 12, which is 72 minus 12, which is 60. Yes, this has to be 2 because when I subtract the bad cases, then 0 is definitely here, so I have only 2 choices for the last digit. Okay, and as you see, again, you got the same result. So it's up to you whether you proceed this way or you proceed that way. In any case, you have to be very careful not to count things twice. You have to consider whether you have repetition, whether you have identical digits in the problem as we see before. I hope this was clear and it helps you to solve your own exercises. Goodbye.